So this week we are going to talk about interpreting architectural designs. After doing the interpretation, we will now do the design itself. The next session will be designing itself. That is now when we will be designing the number of lighting points. We will start the calculations of the number of lighting points and how to determine the lighting points in a room or in a certain building. So our topic today is identifying, interpreting, understanding architectural designs. When we are on site, when you are an electrical engineer, you work hand in hand with architectural engineers. We work hand in hand with mechanical engineers and even the plumbers. And for you to be able to do that, we have to be able to understand the architectural designs. So it's very important to know what things mean. When you look at these things, these are just 3Ds of maybe layouts of this can be a store or a hall or something, a room. So you can see those section. So when it is in a door, you can now a door, the representation of a door normally has that all those big. There's a difference between that wall. There's a block wall there. There are some windows. When there is a window, you can see a window, how the window looks like in the drawing. So when you have the drawing and you are on site and the drawing is presented to you, you as an engineer or a design engineer, you should be in a position to be able to interpret and know what exactly these things mean. Now look at this. This is an addition of now, a continuation of that. It is just this floor plan that has been extrapolated and pulled so that it can become the walls. So wherever there is a window, there's normally you can see this opening to show that this is a window. This is a block, meaning this is a beam that will go up to the end. You can now see when this one is reflected and or is viewed using orthogonal views, you can now see how it looks like. You can now see the difference of that and that. So it's very important to understand and know all these drawings. So we are going to understand today, our main thing will be understanding architectural plans and what is on the plan. What does it mean? What does this represent? So the objective here is to define and explain the various sheets that make up the set of architectural plans, identify the sheets and setting work drawings, and explain information available from each working drawing, then define the most common scales used on architectural plans, explain why scales are important and what information they make possible on a single sheet plan. Give examples of electronic plan scaling aids and software available to estimators and builders. Then explain how these tools help estimators work faster and more accurately. Then explain why section views and details are important plans sheets. How do carpenters and other trade workers use these views? Explain how building information modeling software helps building energy efficient homes. Then architectural plans, we can see here architectural plans and plan sheets. That is we have now. We normally have different specification or sheets that we have. Now, contract-related documents include the final drawing, contract details, specification sheet, the working drawings of the construction, and a set of paperwork which becomes of legal foundation of the project. So each document is a vital for the building process. The various plan sheets listed below make up the working drawing for the builders and subcontractors typically use and develop their estimates. So carpenters will use the same drawing to interpret the design and build the structure. Many people refer to the working drawings to plan the blueprints. In fact, working drawings are part of the complete set of architectural plans. So architectural plans include working drawings, schedules, and other sheets shown in the list below. So many architectural plan sheets are horizontal, sectional views of the building. So the most common plan sheets include the floor plans, the foundation plans, the roof plans, the order plan, and the sheet generally follows the order of the building process. So elevation views are usually before building plans and give builders or homeowners a trade workers a sense of how the entire project will look on completion. So not all architectural plan sets will include each sheet below. So the reason why we need to learn all these things is because people, even electrical engineers, also need to know these electrical plans. When an architect has drawn this building, when you go to site, you should be able to explain that here there is a door. So I'm supposed to drop my switch here. So because when you are doing the slabs, you saw those who have gone to site, and even when sometimes you even when we were in campus, you could see the building that was being done just next to our university. You could see how they were doing the floors or the floor plan. When they're doing the floor plans, normally the piping, we normally call it piping in electrical engineering. The piping is done inside the slabs. It's done inside the slabs when the slabs are being made. So you have to understand the plan because you cannot just lay the pipes anyhow. You have to understand the plan. You have to be able to know where this pipe will drop, where will be my switch, where will be the door, where is the window. So because when the slab is being done, you might not even know where the window is. But when you have the drawing and you understand the drawing, you'll be able to understand that this is where I'm supposed to lie my conduits. This is where I'm supposed to. This will be my exit. This is where my sockets will drop. This is where my. So you have to know all those things and be able to drop the power according to what is expected. So, we can see now the list below of things that are found in the plans. Now, the title and the legend sheets. We have the plot plan. We have the site plan or the site plan. We have elevations, foundation plans, floor framing plans, floor plans, ceiling frame plans, roof planning plans, roof framing plans. We have the window and doors schedule. We have the details of the sectional views, the interior sections. We have the trade plans for the mechanical, electrical, and the plumbing works. We have the specifications. You remember when we were talking about the documents that are involved in tendering documents or the tendering documents that we have. All these documents appeared there. We have the specifications are there, the plans, you find them there because they are part of a contract. So the sophisticated and details of the set construction plans may vary based on the building design. So the owners need and the architect in any case enough details required to help minimize mistakes and facilitate coordination within the various trades. So subcontractors and material suppliers in drawing construction plans, architects, drafters, or builders will illustrate many details in only one place to eliminate the confusion and redundant information. For instance, specifying the same start space in every wall section. That is, it is not required for most plans. So title sheets. Now we are going to go through each and every thing, and we know what it means. What are the title sheets? It's the cover of the sheet of the architectural plans. On a new construction, the title sheet typically has the front elevation view of the home. That is, the title sheet normally includes all permitted information about the primary parties involved in the project. That is, the title sheet will list the architect, that is the designer, the owner of the building, the major subcontractor that are doing, that is the electrical subcontractor, the mechanical subcontractor, and all those subcontractors will be on the title sheet. And it may include a green home certification programs, real seal, and the green verifies information. Other sheets in the plan set will use title block. The title block organizes some of the same information from the title page for quick reference on each page. So plan visualization. Visualization, now what is a visualization? Visualization is now to interpret, now to comprehend what is there. Visualization and visualizing the finished home or addition by reviewing a set of working drawings is a learned skill developed by the builders, so carpenters and other craftspeople. It takes practice to develop the partial skills necessary to visualize the three-dimensional building represented on a two-dimensional sheet of paper. So experienced carpenters can take a visual a vital tour in their minds of the finished building as they read and interpret information in the set of architectural plans. So in this chapter, we covers the sheet plan and draw the mental picture and visualize the information being developed. So when the information is being drawn on paper, we are able to visualize, meaning I put it in 3D and imagine how the house will look like. So that is called plan visualization. Then we have orthographic projection. You remember when you were in your module 1, you learned a technical drawing, and in technical drawing you did the orthographic projections. So now there is an application of the orthographic projection. You don't just learn them for the sake of it. So drafters, engineers, architects, and builders use a system known as orthographic projection to create drawings of 3D dimensional buildings or 2D dimensionals on paper. So ortho means straight line, and its projection provides the graphical representation on the two-dimensional plane. Remember that when we are doing the orthographic projection, we are doing the two-dimensional. We are not drawing them in 3D. But when we talk about isometric projection, then we are talking about the 3D. So there's normally a difference between the two. So when I'm looking at the drawing on a sheet of paper, it is drawn on 2D. I'll be able to see the skeleton part of it. But when I'm talking about the 3D, I'll be looking at the block of a whole drawing. So these architectural drawings normally involve different of such kinds of things. Also, the projection represents objects drawn with a common relationship, that is, they are in scale with each other. Common perspectives and drawing techniques are shown in the figure. We are going to look at the figure. And then the common drawing perspective providing the three-dimensional, that is the 3D, as I had told you, that which is the isometric view. The isometric view places all horizontal lines at 30 angle degrees relative to the horizontal. I think you guys can remember how we were doing our isometric projections and drawings with the vertical lines perpendicular to the horizon or horizon. So with this method, all lines of the cell remain in position. For example, is shown now. We're going to look at the drawings. Now look at these plans. So this one is orthographic projection, and you can see the orthographic projections, how we are projecting. Now this is this side that is projected, the front view, the right hand side of the front view. You can remember how we were doing the views. And now this is the isometric. The isometric, now you can draw it now using the 3D. You can see the 30 degrees, the way we were drawing, and the house is up there. And this is the perspective viewing. You can see the horizontal line is there and the vanishing point, and also from the other side, the vanishing point. So when you are doing this drawing, you can now see the site location, the site plan, it is there. The site plan is just going to show that there's a house that will be there, and there's a location map. You can see the site location map. These are the things that you'll be able to do, to understand. So now, like for example, you will ask yourself, why do I need to have a site plan? You need to have a site plan because it is very important. There is no plan that normally comes without electrical engineers being in, because on the site plan, even on the security side, you need to know the layout. How will the manuals be? Where will be the Kenya Power supply? Where will be the supply point? Where will it supply the point? Which is the middle of the, if this is my site plan. So how am I going to locate the middle of this so that I can distribute the power equally? So how am I going to deal my manholes? Because some of the cables will have to go underground. So you need to understand the site plan. You need to be able to learn what it means by this, what it means by this. So that is why we learn how to interpret the architectural drawings. So when we proceed, we can see now the dimensioning aids for working with architectural plans. So reading the set of construction plans require practice, experience, and special skills. So to quickly read through dimensions or for estimating, a wide range of computer-controlled electronic and manual dimensioning aids are available. So even though these tools usually provide enough accuracy for estimating and general drawing, always refer to architectural plans for exact dimensions and details. So various scaling tools are available to increase accuracy and the speed when estimating that figure. So we can see the architect's scale. The architect scale that they use is the scale that everybody uses, including the civil engineers, the electrical engineers, the mechanical engineers on site. All use the architect scale because it is the scale that architect uses to do the sketch or to do the drawing, the initial drawing. So reading, okay, the architect scale, there are several versions of the architect scales, and the most commonly used is the triangular with 11 different scales, one being a full-size rule. Common plane scale are shown in the figure 8.5. So 8.5 is here, and we're going to see the scales. And the end of each scale has the fraction that is designated the particular scale. So the residential construction, that is 1 per 4 inch is equals to 1 inch. 1/4 inches, that is most common scale used for working drawing, and as shown in the figure. So however, some of the plan sheets, depending on the paper size, building and size of the object represented, may use 1/8, that is 1 inch on the other scale. So be sure to check each sheet for the appropriate scale before taking measurements. So professional tips that are here is that written plan dimensions always take precedence over scaled and measured dimensions. So variations in printing and paper can describe the accuracy of measuring the scale dimensions from the physical plan set. So you can see the rulers that the architects use in measuring. You can see the architect's triangular scale ruler. This one is the triangular scale they use in drawing off. So how to apply the architect scale? Learning to use the architect scale is important to reduce to reading and interpreting working drawings. So follow the steps shown below to refer to the practice with the architect scale and develop accuracy and confidence in reading the working drawings. So the figure in this example is part of the sheet A5 and a detached gauge for this plan, like this specific plan. But the technique can be used throughout any scale set plan using the architect's rule. So this is what it means. This is the steps that are included in reading the architect scale. So number one is find out the appropriate fraction mark of the end of the scale that corresponds to the scale plan of the A5. So the papers normally vary. We have A5, we have A3, we have A2, we have A1. So in this example shown in the figure 8.7, 1/4 is used. 1/4 inches is used. So using 1/4 inch scale, you set the architect's rule to 0 mark and one corner to the greatest to the gauge front. So read across the scale and the other end of the gauge of the garage and note 22 inch. So most of these things we will learn them, or we will learn how to use them when we go back to the face-to-face learning, because some of these things we are just talking about them in theoretical form. Okay. Now, engineers scale, civil engineers scale, you can see there the rolling rule. These things you'll be able to meet them on site, and if you decide to join the design art section, you know, when people graduate, they normally learn in different areas or in different learning sections. So if you decide to join the design industry or the consultancy industry, you'll be able to find yourself in a design and you'll be a consultant. And now electronic scaling tools. Electronic tools are available in scaling plans when estimating two pair types, that is the scale master 2 and the scale. These are now the scales, the different scales that are used. You'll be able to explain to understand them later. So the yellow mark is one scale, foot. You can see how that one is done. Electronic scale, we have already talked about that. The working drawings, depending on the building complexity, the roof design, and other variables, set of working drawings for the residential home may be 5 to 10 sheets for the basic design. So a simple floor plan, a few specifications are possible for roof plan. It is all many carpenters need once the building corners are determined with the site plan. So the point is that working drawings may be very simple or depending on the project and the experience of the level of the builder and the crew members. So using the International Residual Code, experienced carpenters can easily adjust for a particular set of working drawings. So the complexity of the drawing is a factor on determining the plan sheet and size. So the working drawing provide the contractors with for bidding a serve may purpose in the overall construction process. So some of the things that are done is so the working drawings other than physical construction, we have estimating and takeoff. These are things that are normally done by builders and subcontractors. They use working drawings to calculate all the materials and labor that are expected. And permitting, the residential construction and requirement for plans and permitting process varies in jurisdiction. That is, some of the architects create a set of plans specifically for permitting. They may have a slightly different look than the actual working drawings. Then the permanent record, that is a set of working drawings. These are now the importance of working drawings. Why do we need the working drawings? It becomes a permanent record. That is, working drawings constitute a permanent record of construction and design. So along with all the details and specification provided, a set of homeowner for future repairs, additions, and remodeling projects. Another importance for working drawings is the legal record. The working drawings become part of the legal record of the building. That is, if illegal issues arise during the or after construction, courts may use working drawings as a basis for determining the important facts. So project planning for the architect plans. Now you can see this section. These are now typical working drawings that are manually done. We have the main bedroom there, the hardwood. It is made of hardwood. Then we have the very wall there. These are washroom. This is just a dimension. So when we are doing measurements, you can see that between this point and this point, the ruler is doing a measuring. So that is from 0 mark to 18 inches. So you can see this is normally the scale differs, that is representation on the ground and the representation on the paper. Now presentation and elevation viewing style. So presentation view, that is plan book, internet sizes, architect and building may provide a presentation view. This is essentially a tool for selling the plans or home and provides little related to actual construction detail. So presentation views in pencil or color typically show fully developed landscaping, distinctive features, and even people to present the finished home in the favorable light. So unless the owner specifically requires and added perspective provided the presentation drawing. So the whole house elevation view. These are views. We are still doing the interpretation of the different things. So elevation views provide a visual and the scale view of the home's exterior and or interior. So most plan sets include views with each side shown in detail. So elevations include a reference to many specifications for framing the exterior finishes. So roof slopes, ceiling heights, finished floor heights, and roofing slide materials are usually identified on elevation sheets as shown in the figure. So we have different elevation sheets. So we have the roof plan, the roof slope. That is, the roof slope may not be the same for all covered sections of the homes. For example, uh, dormers, shed roofs, and garages may have different slopes. And then we have the ceiling height. That is, the ceiling height are provided uh, on most elevation sheets and may be included on specification or detailed sheets. We have the exterior finishes, that is, the exterior finishes are usually illustrated and noted on elevation. So in some cases, the sheath side of the home will be brick and the other three sides are covered with sliding materials. The topography is now the actual lot grade, that is topography. The estimators calculate the foundation materials and grading work. So elevations also illustrate the home's finish look and the relation of the guide. The interior elevations, the interior now is inside the house. So interior finish work such as cabinets, trim work, and built-in bookcases may have a plan sheet. So with interior elevation, so carpenters know where to set these items. Interior elevations, dimensions, universal design which features like lowered coding or to equipment, universal design heights and details for doors, cabinets, and other features are discussed in other areas of the text. So layout and framing, plan views. So plan views, these are now, most of them are now the four, the cutting edge, that is the plane, the layout of the frame plan. Now how it's laid. Now where is the doors, where the accessways, where the rooms are they located, what are the dimensions. So from the plan views, a cutting plane is horizontal line. You saw that line from the picture, and the cutting object for the better view. For example, the typical floor plan, the doors and windows on exterior walls, so they are in final view. So removing the area above the cutting plane creates a bad eye view. So looking down into the structure, like the example that was given. So the professional tip that is here is that the oldest known plan of the drawing dates back to around 200 BC, and it created the Candle Prize and the city-state in the ancient Mesopotamia. In the ancient Mesopotamia, in this time, the prince was known as the engineer and the builder. The plot or site plan. You know, these things are very important for you guys because you'll need them. Sometimes you'll need to just do a site plan or a plot. When you are given a task, maybe I want you to do this work, or you are given a subcontract, you have to do a plot or a site plan, a rough idea of what it is. Sometimes architectural drawings will be missing in a certain project. You'll be able to make your own sketch of drawings. So a site plan contains information verified by a surveyor, engineer, and others. So it illustrates important features such as utility easements, topography, property lines, setbacks, and elevations. So site plans usually include the building footprint, the driveways, auxiliary buildings, and other constructed features on site as reference. So a plot plan, a plot. Yes, mute your mic. Okay. Nikienda bio sana, you tell me so that we can be together. A plot plan was saying that was very similar to the site plan. It is specifically the recording a piece of land that shows much of the information on the site without a house on it or on the lot. So some of the important aspects include the following. We have the easements, that is, any property easement must be specifically located and identified. It is advisable to check with the court officials and utility companies for restrictions and setbacks related on of property easements. Then we have setbacks. Setbacks, these are the all property setbacks drawn on site plans should be verified with local housing officials before construction begins. And then we have the site plans contains very important information about elevation. Each site plan has an elevation called the benchmark. So benchmark represents a starting elevation that may be the actual elevation above the sea level, or for ease of the arbitrary number like 100 inches. So those are the site plans and the plot. So no, now this is a project that was done. You can now see the plot, the way it looks like. Now the project planning architecture plan. So you can now see the scalings are here. Now the foundation plan, the information of the foundation plan provides a critical dimension for the structural support features. So the height of the cutting plane should set off that is cut through all any windows, doors, or other openings in basement walls on the builder that can define a location. You can see it there. So this is how the plans look like. Okay. So take a look at the information below and note the figure 8.15, the information specified provided by the foundation plans. So foundation wall type and the width and the foundation width was determined by the code designed may not be same for all areas of the building. So they normally vary. Another thing is the window openings, window type, size, and location may not be the same for all locations. Dimension lines, that is carefully note dimension lines and their reference points. They may represent the footing with it for foundation walls, piers, and columns, the footing with it beyond the foundation walls. And then we have concrete. Some concrete specification may be listed on the foundation plans, but refers to specification sheets of all the pertinent details, that is the loop frost lines. Then we have the floor plan. So what is a floor plan? A floor plan, like examples, the figure 8.16, are usually the most information packed of all the sheets. Like the foundation plan, the floor plan cutting plane should be at the height of that openings, and these sheets define the size of the layout of the room, including the electrical, HVAC, and plumbing information if the home design is more complex. So, however, electrical, HVAC, and plumbing may be on separate sheets to simplify the view and help eliminate mistakes and oversights during the estimating and construction. So the floor plan provides the information needed to estimate many materials like studs, drywalls, door, windows, and floor framing. So many plan sets include framing and sheets for floor walls and ceilings as shown in the following section. So we have the room size and layout, as which many dimensions. Be sure of the reference point and the ethical work will match the floor equipment. Then we have the piers and columns. That is the surface contact area of the support framing materials, overbearing support. And then we have the plumbing fixtures like the toilets, the baths, the wash shapes, the shower shapes, spaces. Specification specifies maximum spacing requirements for these fixtures. Reading the floor plan correctly will lay out the walls as critical to assure code complication spacing. We have the electrical and HVAC. So that is the floor plan are used. Okay, the floor plans are used by trade workers and position outlets, switches, home refrigerators, integrated systems, the supply, the HVAC supply, and then that is the high voltage AC air conditioning supplies, the return refrigerators, and many other components of the home design. The exterior features, that is the floor plan, dimensionalize the placement of the decks, porches, garages, and other attachments. Exterior features depending on the design. Exterior features like decks may have detailed specified and illustrated on other sheet on plan sheets. Now you can now look at the south elevation. Now those are the east elevation. Those are the elevations of a building. So framing plans for ceiling and roofs. Ceiling and roof framing plans provide details of all structural components and the layout, spacing on the arrangement of the system. For example, spacing and framing details for all the ceiling joints are noted on the ceiling frames plan. In addition, the size and type of all materials is defined in the framing plans. So a ceiling roof framing plan will show details of framing for green features such as eye joints, raised hill trusses, engineered lumber, or recycled sites. Detailed section views. We have talked about the sectional views. Now look at the pictures. And the sectional views. Then we have schedule specifications. It's a set of architect drawings, and most common schedules and specification sheets is for windows and doors. So throughout the plan, a set windows, doors, and other components have a numerical or alphabetical designator corresponding to an entry on the schedule sheets. So information on the schedule sheet will provide specification, model numbers, material type, size, through efficiency, shown. So the CAD programs for design and energy efficiency. So the computer-aided design software are used to do these designs for both electrical, structural, architectural, and civil and mechanical. They are using the AutoCAD design. And when you were in your module 1, you did the AutoCAD design and you saw how to use the software. So it's very important for you guys to know how to use this software. So design and its estimation software. So today's estimating and 3D modeling software programs, that is a residential and commercial range from entry-level program to highly sophisticated custom programs. A basic example of what is there. You can now see 3D modeling, show cutting plane, and we can use, now we have the floor plan. This is normally now what we use. We're given a floor plan like this, which is a 2D, this is a 3D, and this is a 2D. And then you are given the bedroom, you are given everything. So this is normally what comes from the architect. Once it comes from the architect, now you're supposed to put in the lighting points and the wiring. So the doors are represented by this curved part, and these are the outlets. The windows are there. You can see how the windows are represented. I hope you came to understand. So this one now, like A's are the windows. You can now, A's are the windows, C's are the exits. Okay, so the site plan is there. You can now see how it looks like. Let me just zoom it out so that you can be able to see the construction site, staging areas, lawn, and that, the deck, and everything is there. You can now see how the floor plans are and how they are interpreted. The building information modeling, this is another software. An example of the building information modeling software is the RAM or rate software used for Energy Star Health Rate. This software package provides energy modeling based on the criteria put in by the rater. So such as blower, door and duct blaster testing, insulation, insulation quantity and quality of installation. So energy efficient lighting appliances and heating and cooling equipment use the BIM software, and they use the BIS software rather than provide a detailed analysis on the holder's information. So one of the many features functions BIB software is compared. So these are the interpretations that we have. They're the basic interpretations that we have. So you can see the floor plans and how they look like. This is the shower, the tub, the wall. A continuation is here. The ceiling frame part. Then the framing plan helps eliminate errors in design and makes the carpentry more efficient and not effective. Okay. So the review questions are there. You can review and read at your own time and answer them. What is the importance of the benchmark on site plans? Then how the scales does a rectangular architect rulers, how you use them, and any necessary thing. So I'm done with that slide, and I want to upload another slide. But before we go to that, I would want us to have a break for at least 15 minutes. So in the next, at exactly 12:50, we will be back here. At 12:50, we will be back here so that we can finish the other remaining part of interpretation. And I also want to hear questions of those people who did not understand and what exactly you didn't understand so that we can go through it. So up to this point. Yes, Salad.
Umesema aje nimeenda chuo
Salad.
nikarudi sana. Nasema
Hello. Yes.
nasema nimeenda chuo nikarudi saa hii. Umesema aje?
Ndio umerudi saa hii? Nimesema tunataka kuenda discussion for the next 50 minutes. Tutarudi hapa at 12:50 so that tumalize.
Okay.
So that tumalize the remaining part. Edgar.
Madam.
Say something. Hii last week hatukukutana, watu mmenipotelea.
As last week tulikuwa na cut.
Sasa si nimemiss today. Okay. Now, in the morning, we talked about, or in the first session, we talked about the things, the floor plan and things that we need to know. The architectural drawings. Why do we need to understand the architectural drawings? Number one, we said we need to understand them because we are going to work with the drawings. When you are doing electrical installation on site, when we are on site, maybe you are doing a story building with even 5 floors, 7 floors, or you are doing a single room, or you are doing even a mansionette that is not story. All these things need electrical drawings or working drawings. So mute your mics. I want everybody to mute the mic so that we can proceed. Good. So the main importance why we are learning about interpreting architectural drawings is because we're going to use these drawings on site. When you have a drawing, you just look at the drawing. I've already helped you to identify a window. When you have a drawing and you are on site, you are told that now you are doing the slabs. When the slabs are being done, all the engineers must be there. The electrical engineer has to be there. The architect has to be there. The structural engineer has to be there, so that everybody can make sure that all their sections are correct. The work of the electrical engineer on when the slab is being made is to make sure that the piping is done correctly. I don't know if you have ever seen how piping is done during when the slab is being made. The pipes are laid inside the steel, the steels, the slabs that are going to make the steels. They're being put in. They're not just put in any direction, but we use the electrical drawings. We use the working drawings to make sure that we make our work perfect. So we have talked about floor plans, and we said that floor plans are drawings of buildings with the roof removed as from it. You can now see an example of this. It's a floor plan. It's a drawing. These are 3D. A 3D, the roof has been removed. So when you remove the roof, so it means that it is a section of it. You can only see the floor, but you cannot see the roof. So that is what we mean by a floor plan. They are extremely useful drawings that help explain how the rooms are arranged. Although no one will ever see a building through its floor plan, the image to imagine what the floor plan looks like, architects slice an imaginary horizontal line called the cutting plane or the cutting plane line, about 4 feet above the floor. So everything below the cutting plane is seen in the floor plan, and some important objects above the cutting plane, such as the closet itself, as shown with the without the dashed lines. So a floor plan drawings uses orthographic projection. The good thing with you guys, I'm the one who taught you technical drawing, and I'll talk to you about the orthographic projection, and I know you know what it means. We said orthographic projection is looking at things at straight lines. You look them straight. Now, which means that three-dimensional object, that is a building, is flattened as shown on paper. So when it is flattened, meaning you are doing like an aerial view. When you want the 2D, when we are looking at the drawing as a 2D, meaning the orthographic projection, we are looking, it's like you are flattening everything from the top, from the roof, and make sure that it is on the floor. That is why we call it a floor plan. So these are shapes or figures of floor plans. You can see these are just walls. When it is a continuous part, it shows a wall. When there's this curved part, this means a double door. These are doors. These are entrances. Windows are also represented by some marks. So I'm going to zoom out a bigger drawing so that you can see. Several symbols appear on the floor plan drawings to help coordinate the floor plan with other drawings within the set building plan or prints. So an exterior or interior elevation symbol indicated by the circle tracked inside the triangle. So provides a reference on the page and drawing number. Okay, so a building section, a symbol, is similar to the circular inside the triangle, but it has a line extending from it which ends with the L shape. So building section symbol show the cutting plane line of the section of the drawing. So you can now see like a floor plan of this dining, frozen dining. This is a frozen dining table. This is a floor plan. A floor plan means you are seeing the aerial view. You remember when we were talking in technical drawing, you talked about the aerial view. In the aerial view, you look at the diagram or you look at the object from above. You assume that you are taking a picture from the sky. The camera is on the sky and you're taking the plan. So that is how it looks. And then you draw the 2D, the two-dimensional. So architects use different methods, both written and graphics, to put their ideas on paper. To start the process of designing a building, architects work closely with the owner to develop detailed program, which lists all the requirements needed in the building. So architects then sketch circles and bubbles to represent various shapes or buildings that will meet the needs listed in the program. So these bar diagrams are intended for the architect as they think through their design. So that is it. So this is now the vocabulary used there. We have already talked about the floor plan. The cutting plane is now the middle line. We have the orthographic projection, the plans and prints. When you talk about the prints, we have the blueprints, we have the A3A, the A3. Sometimes when you'll be doing your project, you remember we halted your project because we have not come back to face-to-face learning. But when we'll come back to face-to-face learning, probably in September, we're going to make sure that you people are going to start your project, and you'll be doing prints. And this prints, you'll do a blueprint of the drawings of the projects that you'll do. You'll produce also the normal prints, like the A3 and the A2 designs, even the A1. So exterior and interior elevation symbols, that is a small round symbol indicated by a circle tucked inside the triangle of a floor plan. So you can see that is these are the exterior elevation symbols and the interior elevation symbols. So the difference between this, the exterior is inside a triangle, but the interior is like something like a half a rectangle. So I hope you can see the difference between the two. So when it is this, so it means that this is the exterior elevation, and when you see this symbol, it means it is an interior elevation. So you'll be seeing these things inside here. You can see them. So this is interior, exterior, exterior. So that is what it means. I hope you guys now are able to see them clearly. And then we have the building section symbols. It's a small symbol indicating the circle tucked inside a triangle. And then on the floor plan, it gives the page number and the drawing number. Those things are very important for you. The bubble diagram, a bubble diagram is a simple diagram of room shaped like a circle, not necessarily drawn in a specific scale and used for architects for understanding the relationship between the rooms. We have the function and use description of how to use the building and space. Schematic diagram. Schematic diagram, I had already talked to you about the schematic diagram. It is like a ladder diagram that is used to be able for you to know how the power is supplied or how things are flowing from one section to another. And then the construction drawing is a very accurate drawing that shows the design, location, and dimensions of all parts of the building. So a construction drawing is produced by the architect. Its purpose is to give the contractor all the information needed to construct the building. So when we talk about the contractor, it's not only the electrical engineer contractor. The contractor can be a main contractor who does all the works, both the civil, the structural, the mechanical, and the electrical works. So these people normally need electrical drawings. They are very important drawings in a building. So you can see how they look like. You can see this is now the bubble drawing that we are talking about. It is the bubble drawing. It just shows the relationship of rooms. So meaning that the living room will be next to the hall, will be next to the stairs, will be there. The dining and the call rooms are there. The kitchen will be next to the hall. So the bubble diagram, you can even be told to do a bubble diagram of an installation, and we are given like 3 marks. So you need to understand what the bubble diagram is, and the schematic drawing is here. The schematic is just a drawing just showing this will be a bed, meaning there's no partitioning, but will show you a room that you'll know that the bedroom will be here. No, this is the dining because these are tables and chairs. You will see that this is the main entrance. This is you can see here. This will be the living room, so you see some chairs there and tables. It shows you the rooms. Somebody is writing something. Hope I'm not very fast. You are not clear. Are you sure, Salad, I'm not clear? Can you log in again and see if you can get me clearly? Confirm if you can get me. Can others confirm if they can hear me?
Yeah, you are clear.
Oh, Humphrey is getting me. Salad, can you log in again and get if you can get me, because I want us to move together. Salad. Edgar, are you getting me?
Yeah, I'm getting you.
Salad is not getting me. Okay. I want to know if Salad is back again, so that we can proceed. I think his network has a problem, and I hope I'm also not too fast for so that you guys cannot follow. I hope he'll get to hear us. Okay. So this one down here is now the construction drawing. Now the construction drawing has all the details. You can see the what we had talked about, the sectional views, the exterior views, and the internal views. This one now is a view from this side, meaning these are the stairs. You can now see now this is the final drawing that will be used. You look at this and you know that this is the stairs. These are the rooms. This will be the sitting room. And sometimes they'll even label it. You can see this is the living room. This is the power room, which will be used to supply the power. This will be our kitchen. This will be our entry, because we have a double door there. So this is now the final drawing that the contractor will use in building on site. But all those other sections are also as important as the drawing. So to change from carpet or of wood floors here, that the bubble floor are usually drawn on tracing paper, so they can be used as overlays to rearrange the spaces and to compare the various schemes. So you can see them. You can look at that. I hope Salad is now getting us. Then finally, the last type of drawing is a construction drawing is created from the for the people who will construct the building. That is, a construction drawing has many details, including specific dimensions, the notes about materials, door types and window types, objects such as doors, sinks, toilets, and fixed elements of the home also appear on construction drawings. So some of the vocabulary again are here: the exterior door, the outside door, the stair landing, the thread, which is the horizontal part of the stair where your foot step. The riser, this is the vertical part of the stairs, spacing between the threads where the toes kick. And then we have the open or to below, that is the architect a term used to describe the upper space, floor space for raising the ground. And then we have the bottle wall, which is a unique feature of the F10 house, and the stairway that is lined with sealed plastic bottles. And then we have the power room, which is a small bathroom. The powder room is a small bathroom that has only a sink and a toilet. And then we have unfinished basement, and so on, as they appear on the drawing. Okay. So look at now this. This is a two-dimensional floor. You can see this is a floor plan, and this is a two-dimensional floor. Now it is already done. When you look closely, we have now the person getting into contact with this will actually know that this is what I'm supposed to do here, and this is what I'm supposed to do here. So this is the second floor, the basement. These are the floors, the different floors. The kitchen is there, the door is there. You can see the front porch, that is the doorway where the people get. These are the stairs. Now this is a typical drawing, now a final drawing that will be used with fewer details that is needed and is important to be used. Now another one is there. You can see how it is drawn. So a question comes that, did you know the term powder room was originally used in the 17th to describe the small room or closet where a man or a woman would go to comb or adjust or add more white powder on the wig. So that is where it got its name from. So now this is a first floor plan. You can now see the schematic. When you look at this one is a typical way of the house. So when you look at this bungalow, the way now it appears from the elevation or the views or the plot. Now these are pictures of that drawing. Now when the building is still on, you can now see how it happens. Comparison and planning spaces. Planning spaces year 2020 now lost size. These are now the spaces and the architect rooms. So we have been able to know how to define sketch bubble diagrams for your own home. So these are now things. Think about how the rooms are laid out in your home. Overall, is your home long and narrow, or shaped more like a square? Now use the entire sheet of paper to sketch the bubble diagram. So you can do this at your own times. Now you can now see like this. This is a terrace. This is the family room, the bath, the bedroom, the hall, the stairs, the dining room, the kitchen, the bedroom, the bath, the hall. These are now different students' diagrams of the bubble diagrams of their home sketches. So up to that point, I wish to hear questions from you guys. Can I hear questions? Can we discuss? a few things before we finish the architectural drawing. There are some notes that I uploaded. They refused to upload here, but you'll be able to meet them in the portal. Yes, Edgar. Can I hear from you?
Ani pictures zilikuwa zimepotea nika relogin tena.
Oh, lakini umeona sasa.
Yeah.
Sawa, Salad yeye aliweza kuona Salad? Hassan? Yes, Humphrey.
Yes, niko sawa.
Uko sawa kabisa? So saizi nikikupea drawing ya architect drawing, can you be able to at least interpret and know what it means?
Yeah.
Good.
Mimi but kutumia ile software ya drawing ndio bado kuna shida kidogo.
Kwa nini si tulisoma na nyinyi ama time ilikuwa itoshi hiyo wakati mlisoma?
Unajua hatukufanya practical sana.
Kwani si group yenu si ni nyinyi mlifanya na kina group yenu ilikuwa ni ya kina Anthony? Si niliwafunza hiyo drawing, hiyo soft ama tulifanya kitu kidogo sana. So what you guys can do,
hiyo time tulikuwa tunafanya ya drawing.
Tulikuwa tunafanya kwa sababu nyinyi ndio wale wenye nilipata kama mko halfway, ndio tukaanza kumaliza syllabus kwanza. So what do you